Alright, our next problem is 14.30, and it says that we have a cheerleader whose pom-poms are in simple harmonic motion. That must have been fun to achieve. With an amplitude of 18 centimeters. So let's go ahead and write that in. Amplitude is 18 centimeters. With a frequency of 0.85 hertz. Alright, so those are our givens. The first part of this problem is wanting to find the maximum velocity and acceleration. So we're just going to start with acceleration here, just because that's going to take the most work and we can kind of just coast on down. So from the book we know that our max acceleration is given by spring constant over mass times our amplitude. And now we're given our amplitude, but we don't know what the mass of the pom-poms are, nor do we know the spring constant. So what we need to do is figure out something that we can use. So first, what does this look like? I don't know about you, but this kind of reminds me of the equation for angular velocity, which is given by the square root of our spring constant over our mass. So now we can just square both sides. And now we can just substitute the square of our angular velocity into this equation here. Alright, and now we just need to find what that is, which that is given by 2 pi times our frequency, which we're given the frequency in this problem. So 0.85. So our angular velocity is equal to 5.34 radians per second. So now we just plug that into our original equation here, 5.34 squared times 18 centimeters. But something to keep in mind here is that velocity tends to want to be expressed in meters per second. So we're just going to want to convert this into meters here. So that is going to be 52 times 0.18 meters. Alright, and this up here is radians per second, so that's going to be meters per second. Excuse me, so this is velocity, so it's going to be, because we've got our squared here, it's going to be per second squared. So we have 5.13 meters per second squared as our maximum velocity that can be achieved, acceleration that can be achieved by these pom-poms. So now we have our max velocity, which is given by our amplitude times our angular velocity. So we already know both of those, so we can just plug that in as 0.18 meters times 5.34 radians per second, which is going to give us 0.96 meters per second as our maximum velocity. And I'm going to do the part B of this problem in the next video.